Hello and welcome back to another Physical Sciences 3 lecture. So last time we were looking at naming ionic compounds and finding out their formulae and back and forth through that. So now we're going to look a bit more closely at ionic bonding and why it occurs and how it occurs. So ionic bonding occurs when metallic elements chemically combine with non-metallic elements. The metallic element loses electrons and becomes a positive ion, a cation, whereas the non-metallic element gains electrons and becomes a negative anion. Thus, the basis of ionic bonding is the electrostatic attractive forces that occur between positive and negative ions. Okay, so in this process of electron loss and gain, both atoms achieve the stable energy condition associated with a completed outer electron shell, energy level shell. Okay, good. So a filled outer shell of 8 electrons is called a stable octet of electrons. In some cases, an outer complement of 2 or 18 electrons is a stable state as well. But we'll just focus on 8 mainly. Right, so in an example, complete the following table by showing the electron shell arrangements. The first line has been completed for you. Okay, so if you look at the first one, the aluminium ion lost its 3 valence electrons to get the stable octet. So as a 3 plus cation. Oh, right, so potassium. If we look at potassium and we go to, let's go down to our periodic table. Here we go. Potassium here, 19. So 19 means it's got 2, 8, 8, 1. And then it wants to lose this outer electron to become 2, 8, 8. And it's positive, so it is a cat ion. And I say cats are positive. So cats are positive. That's how I remember it. Oxygen. Oxygen has, how many does oxygen have? What's its number? So oxygen here is 8. Okay, so it's 8 there, which means it's going to have 2 in its inner shell, 6 in its outer shell. It wants to gain 2 electrons to get to 2, 8, and 8. And that's why it has a 2 minus charge, and it is an anion. Okay, so anions are negative. Magnesium. Let's have a look at magnesium. Magnesium here has a atomic number of 12. So that's 12 protons. So that means it will have 12 electrons. So 12 electrons. We go 2, 8, 2. Okay, it loses these 2 electrons to become 2, 8. And so it is also a cation. It's a positively charged one. And we have phosphorus there. Phosphorus, let's have a look. It's got 15 electrons and protons. So we have 2, 8, 5. It will want to gain 3 electrons, so it'll become 2, 8, 8. And it is an anion because of the negative charge. Okay, so sometimes, what's happening there? I'm not sure what was happening there. Sometimes a positive ion in ionic bonding is not a metal. In this course, you need to be familiar with ammonium ions, NH4+, and hydrogen ions. Sometimes the negative ions are formed from a combination of nonmetals, for example, hydroxide ions and carbonate ions and phosphate ions. Okay. All right. Okay, so the example here, consider the ionic compound sodium chloride. It's table salt. So this is one, it's good to remember this one, table salt is sodium chloride. Sodium metal atoms have electron configuration 281. Chlorine non-metal atoms have electron configuration of 287. Each sodium atom loses 1 electron and forms a sodium ion, 2A+. Each chloride or chlorine atom gains 1 electron and forms a chloride ion, 288. Okay. Example, consider the ionic compound magnesium chloride. So here we have magnesium metal, which will lose its 2 valence electrons, and we will have to have 2 chlorine atoms with the 7 valence electrons, because that wants to gain 1. So then we will end up with having 1 magnesium for 2 chlorines, like that. And now let's consider the ionic compound ammonium carbonate, so NH4 2 minus. So these ammonium ions, which are non-metal, have a 1 plus charge. Okay, carbonate atom ions have a 2 minus charge, so we needed 2 of the ammonium ions for 1 of the carbonate ions. Okay, and so that's just an example of how you can treat some non-metals as metals if they have a positive charge, so they're still cations. Okie doke. We'll have a look at the structure of ionic compounds next time.